So I have a program, I will be replicating that program in the form of graphs. If I represent that, so I will be representing that with the help of G of P. Defining node in the sense, the node where exactly I declare the variable. Total logs is defined in two places, one is 10, another one is 16. In the calculation purpose, you have to mention it as a used nodes. Hello everyone, I welcome all of you to yet another interesting session on software testing. Yes, what is that I have in this session? So I will be discussing one of the interesting topic on data flow testing. So guys, what is that I have in the data flow testing? Especially in this session, I will be discussing that. Stay tuned. So yes, let's check out what is the agenda for the day. So I will be discussing one of the important topic, that is definitions and with an examples. So what exactly definitions, what exactly the examples are? Yes. So let's start the session without wasting much of your time. My dear students, so I have some of the important things that I have to discuss with all of you before I get into this session. What exactly data flow is all about? Imagine I have a variable, okay? I have a variable. Say for example, so A is a variable, all right? So what exactly this is all about? Yes, this is a variable. So when will I get the data for this variable and when will I use it? So that is what I will be able to understand with the concept called data flow testing. So please remember, when will I get the value to the variable and when will I use that is what I will be understanding with the help of the data flow testing. So fine, I understood that the complete chapter is focusing only on one thing. So what is variable? When will I get the value to that variable and when are we going to use it? So that is the major thing that you have to remember in this entire chapter. Fine. So when I'm doing this, I will come across with the three anomalies. What exactly anomaly is all about, sir? Anomalies in the sense, I will be getting some of the problems. Okay. So what is that? So please check out the first one that I have is the variable that is defined, but I have not used, that is never used. So that is the problem number one. And the problem number two that I have is a variable that is used before it is defined. What is that? I'm using the variable before I'm defining it. So that is the second problem that I will get. What is the third one that I have? The third one is the variable that is defined twice before it is used. So this is the three problems that I will come across whenever I'm studying the data flow. So fine, what exactly the data flow is all about? So fine, I have a variable and when will I get the value for it and when I'm going to use that. So that is what I'm trying to understand. But meanwhile, I will also come across with three problems. So I will be studying that. All right. So fine. What exactly I will be concentrating in this chapter, especially in the data flow testing? You'll be concentrating on two things. So the first thing, you will be concentrating on the basic definitions. We have some important basic definitions. So I will be discussing that in detail with all of you with examples. So after that, we will be understanding what is program slicing. We will be understanding what exactly program slicing is all about. So this is the two important things that you need to concentrate in this chapter. So fine. So let's start with the first one that I have, definitions. What exactly definitions is all about? Let's start with the first important thing. So guys, I represent my program. Obviously, I have a program, right? Suppose if I say the program, I will be representing the program with the letter P. That's what you need to remember. I denote the program with the letter P. So fine. And I have a graph for the program. I represent the graph. I have a graph. So what exactly that graph is all about, sir? I will be showing that in the coming slide. So I have a program. I will be replicating that program in the form of graphs. If I represent that, so I will be representing that with the help of G of P. What is the meaning of it? G in the sense graph, P in the sense program. So fine, a set of program variables is what I will be calling it as a V. So you need to remember three things here. What is the first one? The first one is program. So you will be calling the program as P and you will be calling the graph as G and you will be calling the variables, whatever you have in the program, as V. So if I have the program, if I'm having a graph, So of a program, so you'll be calling it as a G of P. So this is the basic definition that you should know. Whenever I use G of P, you need to understand that that is the graph of that particular program. So fine, that is the first important thing that you need to remember. Fine, moving forward to the next one, the program graph. So fine, the program graph. So what exactly this program graph? I'm very much curious about it. So can you please show that before you explain this? Yes. So please take a look before I go to that. So guys, this is the program that I have, okay? And this is the graph that I have written, so according to the program. So please observe the line number 1, 2, 3, 4, 5 till 43 I have. So I have used the line number to depict the graphs. So that's what you need to understand. Hope you got the idea now. So let me come back to the definition. So what is that I have? So please observe the program graph. Whatever I say, okay, you should imagine it as, so G of P. That graph is constructed with the statement fragmentations as, so please understand, this is very important, nodes and edges. So you all know, if you have studied the concept of graphs, so what exactly nodes and what exactly the edges. So I'm going to construct the graph with the help of nodes and edges. That is very, very important. So that, please remember one more point, the representation of node sequence. What exactly node sequence? One after the other, you will have the nodes. So if, for example, so guys, this is your graph. This is your graph. So this is what I will call it as a nodes. This is what I will call it as a nodes. So please observe, this is what I will call it as a nodes. And this is what I will call it as a edges. So this graph is made up of a sequence of nodes. Sequence of nodes in the sense, one after the other, one after the other. You have a lot of nodes. So with the help of this, I'm forming the graph is what you need to understand. So fine, you understood what is graph and you understood what exactly, how exactly we are developing the graph with the help of nodes and edges. So fine, we understood that. What is the next thing that I have to understand before I go to the next topic? So guys, the graph has got a single entry node. The graph has got the single entry node, one side entry, okay? No multiple branching. So that's what you need to understand. One side entry and one side exit. That is one of the important points that you need to observe here. All right. The set of all the parts, okay, is what I will be representing with the help of parts P. The set of all the parts is what I'm going to represent with the parts P. That's what you need to remember. This is the basic things, basic terminologies that you should remember. Yes. So, do you call this as the definitions? Of course, I will call this as the definitions. Along with this, I would like to add some of the important things. Climax starts now. Stay tuned till the end. So, guys, I have some 5 important things that I need to understand in this chapter. So, what is that? The first one that I have is defining node. What is the first one that I have? Defining node. The second one that I have is usage node, and the third one is predicate node. What exactly the defining node? What exactly the usage node? So what exactly the predicate node? So why it is in the bold and the rest 2 lines are in the normal font? So guys, I will be speaking with respect to these 3 in this session. So I will be speaking with respect to these 2 in the next session. So total 5 things you should understand in this chapter. This is very, very important. So if I say this chapter data flow testing, the 5 things, even if you close your mind, so it should come to your eyes. What is that? The first one is defining node. The second one is usage node. And the third one is predicate use. What exactly is this? Let's understand this in detail one by one. So what is the first one that I have? Defining node. Defining node in the sense, the node where exactly I declare the variable. The node exactly where I declare the variable. So that is what I will call it as a defining node. So listen to me. I will be explaining the definitions first. Then I will show you practically how exactly you should understand. So what exactly I will be calling it as a defining node. So fine. You understood. The node where exactly I define the variable is what I will call it as a defining node. So fine. What exactly the usage node? Where exactly that value is being used? That is what I will call it as a usage node. And the last one that I have in this session is predicate use. So guys, you will be seeing a lot of loops in the decision making notes. So that is what I will call it as a predicate use. So I will be denoting, or I will be representing that with the help of P use. So let's check that with the help of the chart. So guys, please observe defining node. So before that, you should get familiar with this chart. So I will be using this chart frequently until I complete this chapter. So what is that I have? So guys, I have taken the commission problem. This we have already discussed in detail, line by line in a previous session. So hope you have gone through. Suppose if you have not, I recommend all of you to please, before you come to this part of the session, I recommend all of you to please check what is that I have in the commission problem. So hope you will check that. All right, so I have the commission problem in detail here, and now I have the graph as I discussed with all of you. So here I should find what exactly the defining node and what exactly the usage node is all about. So please understand, remember this chart, okay? So let me show you that. So here I've done a chart for all of you. So in this, I will be showing you, okay, what exactly the defined node, okay, and used node. So let's understand this. So let's take the log price. What is this log price? In this table, I have divided this table into three parts. The first part is all about the variables. I will be listing out all the variables, whatever I am using in the commission problem. Suppose if you are familiar with the commission problem, so this will not be very easy for you. Alright, is it? No, it will be very easy for you to remember all these variables. And I will be showing you what is defined at node and what is used at nodes one by one now in detail. So let's take a look now. So first variable that I have is log price. So where exactly I have defined? I have defined the node 7. So please check that. So what is that I have? Log price. Please observe in this program, log price is defined. Log price is defined in the line number 7. So that is what we have used here. That is what we have mentioned here. That's what you need to understand. So fine. So used at the line number 24. Let's check that. So guys, here we have log price, whatever the value that we have. So we are using it here. Till then, we have not used the log price. That's what you need to check. I have not used the log price anywhere in this line. That's what you need to understand. Hope you understood. So this is defined, okay? This is used. There is a difference between defined and there is a difference between used. So till here, I never used the log price at all. So that's what you need to observe. So fine, I'll show you the next one. So I have stock price. I have defined the stock price in the line number 8. Please check out. So I have defined that stock price in the line number 8. This is where I have defined it. But where did I use it? So please check that I have used it in the line number 25. So in the line number 25, I have used it. So till there, I have not used is what you need to understand. So guys, in the same way, look, please observe what is the next variable that I have. I have barrel price. So barrel price was defined in the line number 9 and used in the 26. So guys, check out. So the next one is barrel price and it is used in the line number 26. So this is how we have done a chart, okay, to understand where exactly we have defined and where exactly we have used all the variables. So hope you understand the different concepts with respect to the defined nodes and the usage nodes. So if you go through this table, so you will get the complete clarity where exactly we have defined this variable and where exactly we have used it. So say for example, sir, here we had only one nodes. So let's understand. So what exactly total logs is all about. Okay guys, let's check the next example that I have, that is total logs. When it comes to this example, I have two defined nodes. Please observe. So this is the next type of example that I've taken. So how can we have two defined nodes? That's what I'm going to explain now. So please observe. So total logs is defined in two places. One is 10, another one is 16. So I have taken this example particularly because those who are referring the textbook, so please understand, in the line number 12, they are supposed to give this as total logs. It is printed in a mistake way, like, they have printed it as total barrels. It is supposed to have total logs. That's why I have taken this purposefully. Those who are referring it, so please understand it and read it as total logs. So that's what you need to understand. So here we have the total logs that we have defined. So fine. So total locks, you all understood. So it is defined in the line number 10 and also it is defined in the line number 16. So guys, even this, we also treat it as a defined nodes. We also treat it as a defined nodes. Two places we are defining it. Alright. So even this, I will be treating it as a definition. I will be treating it as a definition. So fine, where exactly we have used it? 16, 21, 24. So let's check. So line number 16, yes, I'm using it here. Line number 16, I'm using it here. And then where is the next one? So 21 and 24. So again, total locks, I'm using it here. And also I'm using it in here, total locks. That's what you need to understand. So line number 16, 21 and 24, I'm using the total locks. That's what you need to understand. Wherever you are using it, so you, in the calculation purpose, you have to mention it as a used nodes. So n number of nodes if you have used, please mention all the n number of nodes value is what I would like to tell you at this point of time. Even you can define in n number of places. Sir, how can we define in the n number of places? It is possible. So I told you when I was explaining, this is a very important point that you need to remember with respect to so definition use path and definition clear path. When I come to this topic, I will explain a very interesting stuff with respect to defining the nodes. Alright. So but as of now, you can just understand so what exactly, how exactly they are defining it, how exactly they are using it. Your concentration should be only on that. Okay. Let's only understand that topic and then we'll move forward to the next topic with a different example to understand it in a better way. Is what I would like to tell you at this point of time. So fine. So hope you understood. So how exactly we are using these variables at our definition nodes and the usage nodes. If you refer this table, so you will be able to understand where exactly we have defined and where exactly we have used. So that is what you have to list out. So using the graph or the program that we have with respect to the commission problem is what I would like to tell you at this point of time. So hope you got to know what exactly the definition node and the usage node. But when it comes to the predicate, so guys, so you need to understand, so predicate in the sense, can I call this as a predicate node? Yes, you can call this as a predicate node. So why are you calling it as a predicate node? So because I have the condition, I have the loop here. I have the loop here. So this is what I will be calling it as a predicate node. This is what I will be calling it as a predicate node. Again, I have the line number 29. So can I call this as a predicate node? Yes, you can call this a predicate node because you have the condition here. So guys, this is what we call it as a predicate node. That's what you need to understand. So you have learned define node, you have learned usage node, and also you have learned the predicate node. So in the coming session, I will be discussing the very important concept, that is definition use path and definition clear path. In my next session is what I would like to tell you at this point of time. So it's time for all of us to wind up the session. Thank you, everyone.